Hello, in this exercise, we create our container via code. We then create our grid in the container via code also. We then add some elements in some places of the grid. We trap click events for checkboxes and buttons, etc. Watch carefully. We have created an empty page named Manual Grid. Let's define a variable that will be our container for the page. We use the addContainer method to add the container. The parent holder for this container is this page. We have defined a variable named here that links to the page template. Each element should have a unique ID. Let's give ours its ID. The last parameter indicates whether the container is fluid or not. Documentation on the Vuetify API does indicate which other properties you can specify. Let's inspect the page to see if this container is added. This will be added inside the router view, which is inside the main element as our layout. We now need to build the grid for this container. You can also decide not to use a grid, however for a nicer display we use it. To add a grid, we need to add rows and inside those rows add columns. We use the AddRows method which expects the number of rows to add. The rows will start from row 1 until the number of rows. Let's add the columns that will be inside this row. We will use AddColumns method here. It expects the number of columns to add and then their sizes. In this row, we want one column, spanning 12 spaces. So we have our 1C1 here. We now need to ensure that the code to build the grid executes. Let's call it. We can only add elements after the grid has been built. This is exactly the same thing that build grid did when we checked it in the designer to build our grid. Now when we run our app, we should see our grid in design, which will help guide us where to put elements. Now we can see the row and column we added. Each row and column identifier takes the name of the parent. This ensures that all grid coordinates are unique. Even inspecting this element, we are able to see from the developer console how it's created. Let's add row 2 to the grid. It will have 2 columns, one spanning 11 and another spanning 1. We specify that the first column will span 11 spaces across all divides, and the second column will span 1 space across all devices. We are adding a new row to existing rows, so the row number will be incremented, thus row 2 column 1. In the same row, let's add the second column, which will span 1 space. This is now indicated in our grid. We will add other rows just to demonstrate this. The first column of the second row was R2C1, the second column by default will be R2C2. We add other rows and columns. Let's get the ID for the first row and first column in the grid. Our console log gives us this. Each column in the grid has a unique identifier. This is what we will use to add child elements to each column. The name of the first column in the first row is mangrid R1C1. Remember, we gave our container the name of mangrid. Let's add more rows and columns and see what happens. We add the third row R3. Let's rather use the shortcut methods this time around. AddColumns 10 will add a column that spans 10 spaces for medium and large but 12 for small. AddColumns 2 does the same by adding a single column that spans 2 spaces for medium and large. We have changed the number of columns to be 2. This will then create row 3 and row 4 with 2 columns each, the first column 10 and the second 2. Let's enlarge the screen as this has taken a small device approach. Those are the 2 rows we added with their 2 columns each, 10 plus 2. As you can see, the row number is increment from the last row you added on the grid. So it's always a plus increment. When you code your grids like this, with show design on, at least you are able to see how your grid will look like. You can add more rows and more columns, then in each add another element. Let's add a 9 plus 3 row. We do this with the shortcut AddColumns 9P3. Let's do also a 8P4. If you are curious, you can open the source code of the provided library and investigate yourself what that does. You will note that it's 2 calls, AddColumns 8 and AddColumns 4. It is recommended that when you design your layouts, you use the grid first. You need to design how your grid will look like and then place controls in it. So far we have created 5 rows to demonstrate this. Each row has different column sizes, based on our fictitious design. A7 plus 5. We also add 4 columns, each spanning 3 spaces. and also 3 columns, each spanning 4 spaces. Our 6x2 will create 6 columns, each spanning 2 spaces. As you can see, we have 10 rows now. A nice grid we can relate to. The container you have created here, you can create it inside any other element. Actually, you can place any element inside another element and design your user interface to your heart's desire. Let's create a row with different column sizes, however the total size will equal to 12 spaces. We do 1, then 3, then 6, this makes 3 columns with 10 spaces in total. We add 2. Then the row equals 12 spaces. We have 4 columns on this row. The first column takes 1 space, the second column takes 3 spaces, the third column takes 6 spaces and the last column takes 2 spaces. Our last row is added. Let's now add some components to the columns. We will use the column coordinates. R11, C2 for example. We add components to the grid after the build grid call. We dimension an image Vue element. This is just an enhanced Banano element. We have done the Banano element basics 101 before on that. We are adding an image to this code module, thus the use of me, we need to give it a parent ID, that is the ID of the element that we will place it on. We had defined a variable named R1, C1, and assigned it the container row 1 column 1 name, we will use that. As each element on the page needs to have a unique identifier, our image ID is imgx. We give it the URL for our image, an alt, a width, and a height. We will not pass additional attributes to the image, thus null. Additional properties are listed in the API for each element. As soon as refresh our page, we see our added image. Like I said, you can add any element inside any other element. You just need to specify the parent element. When we hide the grid design, we are able to see the final product. It is important when you design a grid you do not have irrelevant rows, but design according to what you will need. Let's add more elements as we wish. This time we add a text field. This should be placed on the second row, column 1. Remember, this column is spanning 11 spaces. So our text field will be longer. For two-way data binding of the text field, we specify a vModel. We will use the getData method to read the value of the text field, and we can also use setData method to set its value. Our IntelliSense is guiding us in terms of the expected variables. You can read more about the text field on the API and apply the additional properties that you might need. Let's bind the Vue element to this page. This ensures that our data bindings and our events for the element we are adding will work. We then initialize the value of our text field vModel. This is another important step. You need to initialize the state of any state variable you create. There we go, we now have an image and a text field. The max length of characters to be added to the text field is 20. We can also apply additional properties outside the definition phase. Let's make the text field outlined. Please note that not all API properties are implemented this way. If the property setCall like outlined does not exist, you are welcome to use selector as demonstrated in the Banano Element Basics tutorial. So far our interface is coming to life. We created a grid and are now placing elements inside it. If we turn on our grid design visibility, we are able to see on the grid the where of each element. Let's add a button and then we will link a click event to it. We are still running our app in design mode. Let's place the button in the 6th row in the first column. Its ID is btn1. We define its label. We set its color to primary. We then bind its state and events to the page component. Binding the button creates the VON-click binding, adds a callback to the methods collection. For that to work, the callback should exist on the page scope. The button now exists, but does not have a click event binding because the callback method does not exist. The callback method should be the element name and underscore and the event. Our button identifier is btn1. So we create the callback using the button ID and the event, so we create btn1 click, it receives an event. When the button is clicked, we get the data bound to the text box and then show it in a snack bar. We have defined a global method to show snack bars that can run in any component on the app. We have created the callback method. The library has detected that the callback now exists. It sets the AddClick attribute, add the method to the methods collection, and now our event works. If you don't bind your elements, their expected events and data bindings will just not work. That is how this library is built. Let's add a checkbox. We will add a click event to the checkbox. When checked, we want the checkbox to return yes, and when unchecked, the value should be no. When the value is no, we want to show an alert. The checkbox ID is checkAgree, so our event should start with checkAgree. The data binding for the checkbox is agree. We set the true value and the false values as yes and no. Let's create the click event. When clicked, get the returned value from the data binding and check if it's no. We provide the alert details. An alert is just a dialog we created. It was discussed in the dialogues tutorials. We refresh our page. As soon as the checkbox is clicked and the returned value is no, the alert fires. Let's see this without the grid design. Beautiful, isn't it? Let's add a gender selector. For this we will use a radio. We first need to define the list of items the gender will be displayed from. We then link this to the radio group, also ensuring that the data binding is done. We create an array of objects that will be the data source for the radio group. M stands for male and F for female. A person will select female, we will get F. A person will select male, we will get M. We add the radio group. Let's add it on row 3 column 1. The source of the radio group items will be named gender list. We need to have the list saved to that state name. We bind each radio item with a key based on the ID property in each object. We bind the label to the text property in each object. We have made our radio items to show on the same row. Here we were demonstrating creating grids via code, adding elements, linking events, data binding, alerts, snack bars, etc. That's our part 30. Subscribe and enjoy.